So this is notes. This is the attached online for practice problems. So let's just read through this one first, and I'll kind of address an issue that will come up sometimes. Rosie is an aging sheepdog in Montana who gets regular checkups from her owner, the local veterinarian. Let X be the random variable that represents Rosie's resting heart rate and beats per minute from the past experience. The vet knows that X, which is her heartbeat, has a normal distribution with sigma equals 12. The vet checked the manual and found that dogs for this breed have a mean of 115 beats per minute. Over the past 6 weeks, Rosie's heart rate measured 93, 103, 110, 89, 112, and 117. The vet is concerned that Rosie's heart rate might be slowing. Do the data indicate that this might be the case? All right, so as I would have read through that, what are some things that I should have marked, circled, whatever? Okay, I heard sigma, I heard mu. What else? Normal distribution. Beats per minute are going to be my units, so I might want to write that. Now, the part that some of you are going to have an issue with here. Where do we start with state? What's our first thing we do in state? Population. So what do you think our population is here? And I'm telling you, some of you are going to have an issue with this. So some people are going to think all of Rosie's resting heart rates. What else, based off of the problem, do you think it could be? All sheepdog, because it gives us the mu of all sheepdog. What else? There's one other possible answer I think you would. So let's go backwards. Our sample, those 6 heart rates, are for who? All right, so let's think like extending it out to a broader group. We could think it out to a broader group as Rosie. We could think it out to a broader group as what? All sheepdog. Or we could think it out to a broader of just those measurements were when? Rosie in the last 6 weeks. This is kind of a picky one, but I like starting with it because we can have the conversation at the beginning. If it were all sheepdog, would that be a good random sample? No. Does it say that this is a random sample? No, which means we cannot do what? Generalize the population. Well, what's the whole point of this problem? To see if her heart rate is slowing. So do we really need to generalize this to like all sheepdog? Do we really need to generalize this to her and her whole life? So we really only want to be dealing with the last 6 weeks anyway to see if it is slowing. So some problems like this, you guys are going to look at differently. And one person's going to say the population is sheepdog. One person's going to say the population is all of Rosie's heart rates. And one person's going to say it's only her heart rates in the last 6 weeks. I would accept all 3 of those here because you're correctly applying it to the larger population. This problem is vague. As long as you choose one that works correctly and you use it through the whole problem, that's fine. My suggestion here is because the way I worded it when I was asking you guys that question, because we really don't, we want to think about like the way the problem is. We're most concerned with how she's doing now to see if it's slowing. So I would think the better population, given like thinking through the whole process, would maybe be just her heart rate in the last 6 months or 6 weeks. If the problem weren't worded to say that we think it might be slowing, I think I would probably just put all of her heart rate as the population. So again, I would accept any of those 3. But since I'm just got to pick one and go with it, let's pick the last 6 weeks. So all of Rosie's heart rates. The wording of this is going to be funny. All of her heart rates over the last 6 weeks, but are we really measuring them that many times? All of her possible, anytime I could have. So y'all are pretty good about wording stuff like that. All Rosie's possible heart rates within the last. The last 6 weeks. So then, and this is where some of you might have this issue with, well, I don't like that definition of population because what's the next thing I do? If I'm you, well, the problem gave us this one, and the problem said it as what? The problem kind of defined you as what? For all the dogs of that breed. Now, because of that, some people might choose to switch this one to be all dogs of that breed. Again, I'm accepting any of those 3 populations. I don't care as long as you stay consistent. Now, if you said something like all dogs, that would be wrong. That's not one of our possible options. So, like, there are wrong answers, but there are usually a couple right answers. Now, we're using this basically under the assumption that what? That's right, which means she's what? Like, not talking about it like math-wise. This would be assuming that she's what? That Rosie's what? Like healthy. So like that's what a typical would be. So like that's where we would think. So we're comparing her versus a typical to see if something's wrong. So even though we used it for the whole breed, that doesn't really seem like that big of a deal. So I would probably still choose right here for her in the last 6 weeks, or for her in general. So how do you want me to word that? The mean what? Meaning what? Resting heart rate? And what?
Mean healthy resting.
Mean, that's a good way to put it. And y'all might change this wording a little bit, that's fun. Mean healthy. But now I want your everything to match once you've made a decision. So if I define my population as just Rosie in the last 6 weeks, let's go ahead and stay consistent here and say, then that's the mean healthy resting heart rate of Rosie in the last 6 weeks. So whatever you choose as your population, be consistent and stick with it when you're doing other things, which includes checking your conditions. All right, so now what? All right, so my null, which is H sub what? What symbol goes first? What has to go here? And what are we claiming that it is? And make sure you have your beats per minute. So 115 beats per minute. I realized I didn't type up the homework from Friday. I realized it this morning. But I think when I walked around and looked, forgetting units is probably one of the bigger things. And then, so this one is H sub what? What's my symbol? Still mu, still going to be 115 beats per minute. And then you said it's going to be what in between? Because I'm testing to see if I have evidence in the direction of less than. And what told me the decision to go with less than? That it might be slowing. So it's wording of the problem is going to tell you the less than there. And so that also tells me how I'm going to shade it, which means is it going to be a one tail or two tail? One tell which direction. Left to right to the left because less than. And what's the other thing I need to put here? So I'm here, right, let alpha equal 0.5, 0.05. Did I write 0.5 yesterday? Yeah. Okay, my last class told me on that, and I realized I played it in your class too. I guess I did it in the notes again. Hold on. So it should be if you're looking at your generic, I said 0.05 and I wrote 0.5. So your generic should say 0.05. And that's all I need to write because one's not given. I usually write since not given to kind of show that I came up with that myself, not in the problem. I'm not going to cut off if you don't write since not given though. There was one other thing that I also did not write in the notes, which was in method that my second class told me. So am I done with state? Yes. All right, so now that plan, I'm writing method. What is my method? Do you see what I did not write yesterday? Why I made my decision here, right? So, since sigma what? So if you've got out your generic for yesterday, where it said ZT here, make sure you have an arrow that says since sigma is or is not known. What's my first condition? What do I put here? Actually think, what do I put here? What's our issue? It's not. And I put something like X. Can't generalize the results. Which, in this situation, isn't what we want to do anyway. So, that's fine. I'm just correctly stating it wasn't random, so I can't do that. We're good. That doesn't really stop us, though. If you're doing something like a weight loss program, would it be important to be able to generalize those results to other people who would do the study? Yes. In this one, does it matter that other dogs, we can generalize it to other dogs' heart rate slowing? No, because we're only worried about Rosie right now. All right, so my next condition is what? Now, this is one, I think I said this yesterday, that people were not 100% doing correctly on the Chapter 7 test. Which one of the things is this one? It's given. So what is given? And so people on the Chapter 7 test were just writing given it was given, or it was given. So given population distribution, how did it say it? It has a normal approximation. So we can use normal approximation. What's our next condition? Which is what? I have people that start to forget to write 10% condition just because they're so used to doing it that they just skip over that. So capital N is greater than or equal to 10 times little n. What was our sample size? So based on the way I wrote my population, what would I say about at least 60? And I could say it as in like, we could have measured, there were measurements. This one, the wording of it, I'll probably say we could have.
You said there are at least 60 measurable possible.
Yes, at least 60 measurable possible outcomes. Yes, that would be fun. So at least we could have measured at least, and it would probably make more sense to be like her heart rate at least 60 times, but I'm not worried about the wording here. So we could have measured at least 60 of Rosie's resting heart rate in the last 6 weeks. The biggest thing is you correctly type back into what you define as population. All right, so what's next? What are some things that the problem gives, or we need from the problem? Our N, which is what? What else? Which we would have to calculate time-wise. Do I think you could plug in and find your X bar? Yes. Where would I find it in my calculator? One variable stats. Time-wise, I'm just going to go ahead and tell you it's 105. What else? Mu is what? What else? So is it one tail or two tail? So I just write somewhere one tail. Like I either write one tail or two tail. And alpha, we already defined as 0.05. So then I go to what? Finding my test statistic. Briefly, very, very briefly, because I said this in 4th grade yesterday, which was not on video. The reason I choose not to write Z or T here is because this alpha, so this one is shaded to the left because less than. So this alpha, having an area of 0.05, has a Z value of negative 1.645. So this would be technically a Z value that goes with your alpha. And because you technically have that one, I don't also call this a Z or T, but it's not wrong to do that. You can actually compare your test statistic to Z like you can your alpha to your p-value, which y'all won't have to worry about. But that's the reason I choose to write test statistic. Writing Z is fine. So my general equation, X bar minus mu, divided by what goes on the bottom? Because that's sigma of X bar. I'm plugging in my numbers. What's X bar? What's mu? Sigma is, and square root of. Now, this is where I do still choose to follow for the most part. A Z we usually write as how many decimals? 2. A T always has how many decimals? 3. So I choose to write this as 2 decimals or 3 decimals based on which one I'm trying to deal with, a 0 or T, so that when you make your connection. So this one, I'm dealing with Z because of that. So when I get this, I get negative 2.04. And I write it as 2 decimals because I'm dealing with Z. And I'm going a little bit quicker here. So I draw it and shade it. This is just like we've done before. It's negative, so it's on the left. And then I shade which direction? Why? Because my alternative hypothesis was less than. For the sake of using the calculator or practice, second distribution, normal CDF. It says your lower bound right now is negative 1E99, which means really far negative. What are we going to put as our upper? Negative 2.04. We still want our mu to be 0. We still want our sigma to be 1, which is Z. So the only thing we put in was this, which is the same thing as looking it up on the Z chart. And when we do all that, we get our area to be what? So that shaded area is 0.0207. Now, this, I don't need you to write on a test. I'm just showing you, hey, this is what it looks like in the calculator. So at that point, I write, you gotta erase this one. So I'm going to write my p-value. Then I'm going to compare to my alpha. So what is my p-value? It's the area just found, which is 0.0207. And why did I not subtract that from 1? Because shade to the left, which is what I looked up. What is my alpha? So now I just either choose right here, it's less than or it's not less than. Is p-value less than? So that tells me my whole decision of how to write my conclusion. Is everybody still looking at this slide? All right, so conclude. Like I said, you're going to have to do conclude a lot on the quiz on Friday, so make sure you're starting to get the hang of this. That's the first time we're writing it, though. We what? Reject. What are we rejecting? Which initially said that so we rejected our hypothesis that mu equals 115 beats per minute. How did we make that decision?
This is the
So that's just, we pick a word to go here and we write it based off, like we came straight from here. So that's why we made our decision. Which means we and now you can be specific here. Hang on. You can be context specific, wording specific. So like if I wanted to write it in terms of like HA, I would write, we do have convincing evidence that the mean resting heart rate of Rosie, what? Numbers. Is less than what? 115. That would be appropriate. So just because this is an example,
Would you not be able to generalize that though, since it was-
oh, Rosie over. I get what you're saying there. That's why I like to write it the other way. Is what did I say? Answer it in the context of the question without numbers. So we have evidence that what happened. And either one of those is fine. Sometimes this one's really wordy and hard to be specific, and this one's easier. In this one, I probably would have just gone with Rosie's heart rate is slow. Now, to answer your question, though, I should have just written the problem as random and not had to deal with that, which is what I would do on a test or quiz. Because then everything else will still apply. One other tiny thing I have to talk about is if it is two-tailed. And when is it a two-tailed problem? So look at number 4 in front of you. Let's just do this one like super quick without doing the whole problem. Let's go straight to do. What is, I don't remember the way this one's worded. Oh, this is what you'd have to type in again. I'll give you the number. Maybe not. Oh, this is bottles of cola. Okay. So, what is the claimed mu? What?
300 milliliters.
If I typed in one variable stat, I would get an X bar of 299.0333. What does the problem not give me? So I'm going to have to find an S from my one variable stats as well. 1.5029. What else do I need? Which is okay, I'm going to cover 2 problems at once. And then what else All right would do? Two-tail, and does this one give us an alpha? And sometimes it'll say a significance level. So like the very end of number 2, which is below the numbers, it says use a significance level of alpha equals 0.01. So sometimes they just write it out like that. Number 3 says can be rejected at a significance level of 5% and then of 1%. It's just asking you to just mark out 5% or just mark out 1% and just do 5% for number 3. So number 3, mark out the 1%. Right. So if I went to this one didn't give us one. If I went straight to test statistic here, that's going to give me X bar minus mu divided by S over square root n, which is 299.0333 minus 300 over 1.5029 over square root 6. What kind of problem are we doing here that we weren't doing before? A t. So I'm going to round this. I'm going to write this out as 3 decimals. So this is negative 1.576. So I just do that to myself as a reminder of if I write 3 decimals there, I'm doing a t. If I write 2 decimals there, I'm doing a z. So in my calculator, in your calculator, that's negative. So I'm going to go ahead and write my negative one. The way we did our calculator just now, what button am I going to go to in my calculator? You're going to go to second distribution and go to what? What? But are we doing normal now?
It's T.
So TCDF, second distribution TCDF, you're still at negative 1e99, but you're going to go up to what now? Negative 1.576. What else does it need from us? Degrees of freedom, which is what? And when you type that in, you get 0.0879.
My calculator's different.
I'll give you a second. So what does not look good about this graph right now? What is it not? What should it be? Should be a two-tailed. Does this look two-tailed? So this is a one-tail. So if I want two-tail, what do I do with that number? Double it. And that's the only difference between a two-tail is you find it, but then you want it on both sides. So your p-value, and I usually write it showing that I do times 2, so when I look it up, I get this number, but so 2 times 0.0879, which gives me 0.1758 as my p-value. Your homework is number 2 and number 3 from that worksheet.